Analyzing the execution of a code using logs is functional, but not necessarily very cool. Especially if you're generating traces from your code. If you are generating traces, maybe you could put those traces to a better usage if you could send them to an observability backend that could plot those traces and spans in a visual manner, and you could use constructs such as timelines and waterfalls to visualize them. In this video, I'm going to show you how to configure the OpenTelemetry collector so you can send generated traces to Grafana Tempo and use Grafana to visualize them. Let's do it. Hello there and welcome. My name is Ricardo Ferreira and I'm a developer advocate here with AWS. In this video, I'm going to show you how to configure the OpenTelemetry collector to send generated traces to a distributed tracing technology called Grafana Tempo. Grafana Tempo is the equivalent of other distributed tracing technologies that you might have seen out there, such as Zipkin, Jaeger, or perhaps any other proprietary technology. But everything that I'm going to show here today is fully reusable with whichever other distributed tracing technologies that support OTLP, which is the protocol for an OpenTelemetry. If they support OTLP for ingesting traces, you can reuse everything that you're going to learn here today. So let's see how this works in the microservice implementation that we have been using for this series. Before we move forward, let me just remind you that the code that we're using here today for demonstration purposes is available on GitHub in the repository that you can see here in the comments below. So when you clone that repository, just make sure to use that specific brand called Build on AWS tutorial. Now, the Docker Compose file as it currently stands already contains the definition of the collector. So the collector, it's receiving all the events using this port 5555. And we also have the definition of Grafana Tempo, which exposes the port 3200 and the 4317. So what we're going to do now is actually edit this configuration file that we currently are providing to Docker to include this intention of sending the generated traces to that port 4317 using the OTLP protocol. So let's edit this file. So as you can see here, you're going to go straight to this session called exporters, and you are going to include a session for the OTLP protocol. So let's understand what we have done here. So we've included another exporter, and this is just a name. It's called OTLP, and we're pointing to this endpoint called Tempo. Tempo is going to be the host name of the Docker container for Grafana Tempo, and the port that it exposes, which is 4317. And since we are not using SSL to communicate with that specific endpoint, we need to inform the collector that we're going to use an insecure communication protocol. So there will be no need for exchanging certificates. Also, we need to include the new OTLP exporters in the service pipeline. So if you go to the pipeline that implements the traces, you go to the exporters, and then you can simply append a new protocol. And you're going to use comma to separate those exporters because this is an array and the YAML definition file. So it might not seem as of right now, but this construct here is extremely powerful. Think about this. We've just added another exporter to an existing service pipeline definition for the collector, and then now the generated traces will be broadcasted both to the logging and to the OTLP. So when this is going to be useful in the real world, so let's say, for example, that you have two distributed tracing technologies for perhaps belonging to different projects or different organizations, and you want to broadcast the same generated traces so both of them can have the same view about what's going on with your microservices. So this is perfectly doable using this approach of a pipeline that can include dynamically multiple endpoints. So this construct here for an OpenTelemetry is extremely powerful. So let's save the changes, and then now we have everything that we need to, whenever a trace is generated from the microservice, is going to be sent to Grafana Tempo, and we're going to be using Grafana to visualize them. So in order for us actually to test this, we need to have the observability backend and the collector up and running. So what I am going to do right now is actually spin it up. So I'm going to use Docker Compose, Docker Compose up -d. So I want to keep them running on the background, and then it's going to spin up for me the Prometheus backend, the Grafana Tempo, the Grafana the visualization tool, and obviously our collector. So let's just make sure that they are up and running properly before we execute the microservice. So yep, everything seems to be up and running and all the containers are healthy. So right now we're going to use our run microservice.sh script to execute the microservice so we can start sending some requests to it so the traces can be generated. So this is our microservice already up and running. So what I'm going to do now is to send a couple requests to it so we can actually see the generated traces in the Grafana visualization tool. So I'm going to use a curl command, and I have probably some history of this sending this command, so I'm going to reuse it. So I'm going to send one request, and I'm going to purposely send another because you're going to see in the observability backend that we're going to have two requests sent to the microservice. So this is the second. So both of them reply a hello world. So it's functioning as expected. So what we're going to do right now is to use a browser to access Grafana, and the traces is going to be there. So here we are in Grafana, and we're actually currently accessing the main page of Grafana that you're probably going to see after you hit localhost the port 3000. So what we're going to do now is access the configured data sources. So specifically, we're going to use the data sources that points to Grafana Tempo. So you can easily do this by going to this option Explore, and in this drop down here on the top, you're going to see that there will be two options, one for Prometheus and another for Tempo, which is the default. So pick up the Tempo one, and you are actually, this UI allows you to search and look for traces in two ways. You can either search, which is what we're going to do right now, or if you know the trace ID. The trace ID is a unique identifier that each traces carries when they're generated by OpenTelemetry. You can simply put them here and then search for it. But since we don't know beforehand the trace IDs, we're going to search for it, and then you can use metadata information such as what is the service name. So the service name is Hello App. And you might be wondering right now, but Ricardo, where the service name came from? So in the previous parts of this series, you probably saw that when we were actually doing the automatic instrumentation of the microservice, we've provided to the script that executes the microservice some metadata information using environment variables. So there is where we've configured that the service that we're using is called Hello App. So if you want to check it out, the other parts of the video, go ahead and see how that was done. And also, we're going to actually, you can filter out by which span it was created. Spans are basically the correspondent of each part of the execution of a piece of code. So a lot of spans will be potentially generated, but when a microservice starts executing its code. So in this case, we have two. We're not going to use them. So you can simply search by service name. So we're going to see all the traces that correspond that are coming from that specific service. You can click on this blue button here called Run Query to actually see all the traces. So as you can see here at the bottom, we have two traces, and this is not a coincidence because remember, when we were testing the microservice, we have sent two requests to it. If we send another request right now, a third trace ID entry will show up here. So let's pick up one, for example, to see how that works. So you can click here on this link that corresponds to this column called trace ID. So when you click it, you're going to see this very useful piece of information that the industry calls the timeline visualization of a trace. So what is a timeline? Because you can see here that the whole execution of the code was broke down into a specific timestamps, and then more importantly, they were put together in a specific order. So how can you read this? The read this is that the microservice interaction started when it hits this endpoint Hello App, specifically on this URI/hello. And from that point on, a child span, this is how we call it in the distributed tracing board. This kind of a second row over here below the timeline is a child span, and the span that initiated the whole transaction is called hoot span, right? So we have two spans. One is the root span called /hello, and from that we've executed the hello app controller, which is exactly the implementation of our method hello. That when we jump to the part where we're going to see how to instrument manually the microservice using the OpenTelemetry SDK, you're going to see how those names are created. But as of now, just realize that all the traces, the root span and the child span, were automatically generated just by using the automatic instrumentation from the microservice that we use it using the OpenTelemetry agent for Java. That, as you might have learned so far, it's called the black box instrumentation approach, an approach where you instrument your code without actually changing it. So now that you've seen how the OpenTelemetry can actually be used not only to generate traces but to visualize them, we can now go back to the point where we can rediscuss the instrumentation process, but taking a closer look at how you can actually use the SDK to create your own traces, your own spans, and the multiple approaches that are available in the SDK to do that. See you next time.
Hey there! Thanks for checking out this video. Remember to give it a like and share with your community. Then hit subscribe and the bell for all the latest content that will help you build on AWS.